Inside China's factory producing genetically modified mosquitoes. China has built a factory that produces genetically modified mosquitoes by the millions and releases them all into the wild on purpose. Last year, dengue fever infected over 14 million people worldwide, the highest number ever recorded in human history. To put that in perspective, that is more people than live in the entire state of Illinois, all struck down by a disease carried on the wings of a single insect. Take that in for a moment. Most people have no idea this factory even exists, but what's happening inside it may be the most important public health story on the planet right now. Here's where it starts, with the deadliest creature that has ever walked, crawled, or flown on the face of this earth. The deadliest animal alive. You already know sharks. You know lions. You know the kinds of animals that show up in nightmares. But none of them come close, not even slightly. The single most dangerous animal in the history of humanity is the mosquito. Biologists estimate that across all of recorded human existence, this insect may have killed more people than every war ever fought on this planet combined. Today, it still ends close to 1 million lives every single year, more than every predator on land, more than every venomous creature in every ocean. Nothing that has ever existed on this earth has ended more human lives than a 4-millimeter insect that weighs less than a raindrop, and right now it is accelerating. Dengue fever is the fastest spreading mosquito-borne disease the world has ever seen. In 2024, the planet shattered every record ever put on paper. Over 14 million confirmed infections across more than 100 countries, nearly 10,000 deaths. Cases had doubled compared to 2023, which was itself already a record year. And compared to just a decade earlier, global dengue cases have risen 12-fold, 12 times. In 10 years, that is not a trend, that is a countdown. But the numbers alone don't tell you what dengue does to a living person. It starts as a fever fast, high, and unrelenting. Then the headaches arrive, the kind that feel like your skull is being crushed from the inside out. Then the joint and muscle pain, so brutal and so all-consuming that the disease has carried a second name for over a century: breakbone fever. Your bones don't actually break. They just feel like they are, every minute, for days on end. In the worst cases, the ones that fill hospital wards and overwhelm ICUs, internal bleeding begins, organs begin to set. Shut down in sequence. And there is no cure, no antiviral, nothing to hand a patient except fluids, and the hope their body is strong enough to outlast what the virus is doing to it. The world's weapons against this disease are failing. The insecticides that once wiped out entire mosquito populations in days are increasingly useless. Generations of mosquitoes have evolved resistance, adapting season by season faster than our laboratories can respond. Climate change is opening new territory for the mosquito every single year, pushing its habitats further north, higher in altitude, deeper into cities that have spent their entire history never once having to think about dengue. The playbook is running out of pages. The disease is not slowing down. For decades, scientists understood that the only way to truly stop this was to go to the source, not treat the sick after the bite, not spray and watch resistance rebuild inside a single season. Eliminate the mosquito's ability to spread before it ever gets the chance to land. The question was how. And in a laboratory in southern China, one man believed he had found the answer hiding inside the mosquito's own biology. But what he was about to attempt had never been done at anything near this scale. And almost no one around him believed it was possible. But this was only the beginning of what would become the most ambitious biological weapon ever constructed. The man with the invisible weapon. His name is Zhu Yongxi, a microbiologist splitting his time between Sun Yat-sen University in Guangzhou and Michigan State University in the United States. The kind of researcher who spends so long on a single problem that the rest of the scientific world starts to wonder if he is obsessed. For years, Xi had been fixated on a bacterium called Wolbachia, a naturally occurring microorganism found quietly inside more than 60% of all insect species on the planet. Butterflies carry it. Dragonflies carry it. Moths and fruit flies and beetles all carry it. It exists peacefully, invisibly, in the cellular machinery of insects across virtually every ecosystem on Earth. But the Asian tiger mosquito, the specific species responsible for transmitting dengue, Zika, and chikungunya across the most densely populated parts of Asia and the Americas, does not carry it. And that one biological gap, that single absence in a single species, was the key that she had been waiting for. His theory was this: what if Wolbachia could be introduced into mosquito embryos before birth, injected under a microscope at the cellular level, reprogramming a brand new line of mosquitoes from the moment of their creation? And what if those mosquitoes, when released in massive numbers into the wild, triggered a biological chain reaction so deeply embedded in the rules of reproduction that nature itself could not undo it? The mechanism was almost elegant. When a Wolbachia carrying male mates with a wild, uninfected female, something goes wrong at the deepest level of biology. The eggs form normally, but they never hatch. The embryos simply fail to develop a process scientists call cytoplasmic incompatibility. The female lays her clutch. She waits. Nothing comes. And the detail that makes this trap so perfectly devastating is this: a female mosquito typically mates only once in her entire lifetime. One mating. A lifetime of dead eggs. Every single clutch she ever lays nothing. Flood a wild population with enough of these males, and the arithmetic becomes merciless. The wild females keep mating. They just keep producing silence. But G wasn't going to theorize his way to a conclusion. He needed data. And in 2015, he got his first real chance. His team released 500,000 Wolbachia-infected males onto a small island in Guangzhou, a contained environment where researchers could track every outcome. Within 3 months, the wild mosquito population had dropped by half. Then came the larger, 2-year trials across 2 test islands in the Pearl River near Guangzhou. In 2016, adult females in the target zones fell by 83%. In 2017, that number climbed to 94%, not a reduction. A near-total collapse achieved without a single drop of insecticide, without measurable harm to any other species, without changing anything about the environment except the bacteria carried inside one type of male mosquito. The results were published in Nature. The scientific world stopped and read them twice. And for Xi, the question was no longer whether this worked. The question was how fast it could scale and how big it could go. For Xi and his team, the bigger problem wasn't skeptical scientists. It was engineering. Because turning a laboratory breakthrough into a citywide public health operation required something no research grant had ever funded before. It required a factory. And what they built next was unlike anything the world had ever seen. Inside the factory, tucked inside a technology park in Guangzhou's Huangpu district, sits a building that looks like nothing. No dramatic signage, no visible security. No suggestion from the outside that anything unusual is happening within its walls. Just a low-rise structure in a city full of them, blending into its surroundings like it wants to go unnoticed. But walk through the doors, and everything changes. The air hits you first warm, thick, and carrying the faint specific smell of standing water, the smell of something alive and multiplying in every direction. Then the hum registers, low, constant. The sound of environmental systems working to hold temperature and humidity at the exact levels the mosquito needs to develop on schedule. And then you see the trays. Long, shallow, water-filled trays stacked floor to ceiling, covering every surface in every room, each one writhing with larvae at some stage of development. Millions of them, all at once. This is the world's largest mosquito production facility, 38,000 square feet, 4 separate production workshops. At full capacity, it produces 20 million sterile male mosquitoes every single week. The process begins smaller than the human eye can track without help. Researchers use microscopes to inject Wolbachia bacteria directly into individual mosquito eggs. Painstaking, precise, irreplaceable work that establishes the founding infected colony. Those first-generation mosquitoes breed, producing clutches of eggs that are harvested daily and transferred into the production trays to develop. Larvae hatch and feed and grow, transforming through their stages until they become pupae, small dark comma shapes floating silently near the surface. Each one containing a mosquito in the final hours before it becomes airborne. At that moment, the clock starts ticking. And so does the most critical, most human, most irreplaceable step in the entire operation. Because here is what no amount of automation has been able to fully solve. In a room the team calls the sex separation room, workers spend 4 hours every single day doing one thing by hand, sorting male mosquitoes from female ones. Not by machine, not by algorithm, by hand, using a glass sieve-like device where the physical size difference between male and female, a difference measured in fractions of a millimeter, determines which insects pass through and which do not. The larger females get caught. The slimmer males fall through into the water below. The females are destroyed. The males are collected, allowed to complete their development into adults, and packaged for deployment. Getting this wrong even slightly could unravel everything. If a Wolbachia-infected female escapes into the wild and mates successfully, her offspring carry the bacteria, and infected females can mate successfully with infected males. Meaning, instead of suppressing the wild population, a contaminated release would be feeding it with a new line that is immune to the very trap the entire program depends on. So workers armed with electric rackets patrol the facility continuously, hunting escaped females mid-flight. The researchers who work there will tell you plainly, they get bitten regularly. Occupational hazard. This is meticulous, physical, unglamorous daily work, and the fate of millions of people rests on it being done right, every single morning, without exception. Once sorted and matured, the males are loaded into containers and transported out across the city. From April through November, the peak of dengue season in Guangzhou, tens of millions of sterile males leave this building every single week, deployed on foot through dense urban neighborhoods, loaded onto drones, and dropped across village rooftops and riverbanks. Released from slow-moving vehicles into residential zones where children play outside in the evenings. An invisible army pouring silently out of one building and dispersing across a city of 18 million people, and every single person walking beneath them never sees a thing. But once those mosquitoes hit the streets, something extraordinary begins to unfold, and the data coming back from the field is the kind that makes epidemiologists read it twice and then call a colleague. A city fights back. Guangzhou is exactly the kind of city this disease loves. Hot, subtropical, threaded with rivers and canals that provide endless breeding grounds across the better half of every year. For decades, the city had experienced dengue outbreaks with grinding, predictable regularity seasons where case counts climbed into the tens of thousands, where hospitals struggled to keep pace, where entire neighborhoods treated every standing puddle as a threat. When the factory's sterile males began flooding the city's districts at scale, the results didn't arrive immediately. Mosquito populations have inertia. But by 2018, the first full season of city-scale deployment in Baiyun District, adult mosquito density had dropped by 59% compared to previous years. Then, in 2019, 70%. Not a weather anomaly, not a seasonal fluke. A sustained, deepening year-on-year collapse in the wild population, the same areas, the same methodology, the same result getting stronger with every single cycle. But the numbers from one specific village told a story that went beyond anything the district-level data could capture. Xiaxi village sits in the hills of Baiyun District, surrounded by streams and dense vegetation, prime mosquito terrain of the highest order. Before the program began, dengue appeared in the village every year without fail. After releases began in 2018, deploying approximately 1 million sterile males at a time, once or twice weekly. By ground and eventually by drone, making Xiaxi the first site in China to use aerial release for mosquito suppression. The control rate of the Asian tiger mosquito hit 98%. The highest figure ever recorded anywhere in the world for this approach. 7 years into the program now, it has never fallen below 90%. Dengue cases in the village have effectively ceased to exist. But China wasn't done. Because suppressing a village is one thing. What came next was a live epidemic. In the summer of 2025, chikungunya spread by the same mosquito, causing the same devastating joint pain, carrying the same absence of any cure, tore through Guangdong province at speed. The outbreak was centered in Foshan, directly neighboring Guangzhou. The factory immediately ramped production. Teams deployed into Foshan alongside existing Guangzhou operations, releasing waves of sterile males directly into the epicenter of a live, spreading outbreak in real time. Authorities later credited the intensive releases as a key factor in the epidemic being brought under control. This was no longer a controlled field trial. This was emergency biological response, a living public health weapon, deployed mid-outbreak against a disease actively moving through an urban population. And it worked. The program had crossed a threshold most scientists had assumed was still years away. And as news of what was happening in Guangzhou began spreading through the global public health community, a very different and much more uncomfortable battle was already taking shape. The debate the world cannot ignore. Here is where the story gets complicated. Because releasing hundreds of millions of bacteria-engineered insects into open environments, however extraordinary the results, is not something the global scientific community, its regulators, or the public has agreed to accept without a fight. The first question is the one that no honest researcher can fully answer yet. What happens downstream? As Wolbachia-infected mosquitoes are consumed by fish, by birds, by frogs, as they move through the food chains of entire urban ecosystems over years and decades, what does the bacterium do? Nobody knows. The long-term ecological studies do not exist yet. They cannot exist yet, because this has never been done at this scale before. What is happening in Guangzhou is, by any honest assessment, the largest sustained open-air biological release program in the history of human civilization. And it is scaling faster than the science of its consequences can keep up. Then came what happened in Florida, and it shook the entire field to its foundation. A UK-based biotech company called Oxitec had developed its own modified mosquito, genetically engineered so that female offspring inherit a lethal gene and die before reaching adulthood. The science was serious and peer-reviewed. Trials in Brazil and the Cayman Islands had shown population reductions of up to 90%. But when Oxitec moved to deploy in the Florida Keys, a public comment period on the proposal drew 31,174 responses in opposition and just 56 in support. Residents testified that they had never been meaningfully consulted, that approvals had moved forward while they were barely aware, that nobody had asked them whether they consented to having their neighborhood used as the testing ground for a biological experiment. The backlash was so sustained and so explosive that it reverberated through every mosquito control program operating anywhere on Earth. And it wasn't just Florida. In Malaysia, trials were halted under public pressure. In communities across Latin America and the Caribbean, the words genetically modified alone, regardless of the specific science, regardless of the safety data, were enough to destroy public trust entirely and bring programs to a standstill. The lesson being etched in real time was merciless. You can have the right technology. You can have the peer-reviewed results in the world's most respected journals. And you can still lose, completely and publicly, the moment the people whose ecosystems are being altered feel like they were never given a voice in the decision. China's program has moved more carefully on this point. The Sun Yat-sen University team conducted their original trials only after obtaining consent from the majority of residents in targeted communities, a standard the Oxitec rollout demonstrably failed to meet. But as the Chinese program scales from individual villages to city districts to an entire metropolitan region of 18 million people, the question of what genuine consent even looks like at that scale, and whether it is structurally achievable at all, becomes harder to answer with every new season of expansion. For Xi, the most pressing problem has never been the opposition. It has always been the clock. Because every week this technology is not running at full capacity somewhere new. Thousands of people are getting sick who did not have to. The virus does not pause for ethical review. The mosquito does not wait. And the factory keeps producing its millions every single week, whether the world has made up its mind about it or not. The war goes global. Right now, 5.6 billion people live in regions where dengue and related mosquito-borne diseases can reach them. That is 70% of every human being alive on this planet, at risk from the bite of a single insect smaller than your fingernail. And climate change is expanding that zone wider every year, pushing mosquito habitats further north, further into Europe, further into cities and countries that have spent their entire history immune to this threat, suddenly waking up to find it at their door. Last year, Brazil alone reported over 10 million dengue cases and more than 6,000 deaths in a single calendar year. The government declared a national public health emergency. hospitals overflowed. Entire districts ran out of beds. And this was just one country, in 1 year, from one insect. The team from Sun Yat-sen University has already announced plans to bring their factory model to Brazil. The mosquito production facility that started in one building in Guangzhou is about to meet the world's worst dengue crisis head-on. And the world is watching to see what happens next, because if it works at the scale Brazil demands, then everything changes. The conversation stops being about one factory in one city in southern China and starts being about a new global standard for how humanity fights infectious disease. The economics are beginning to turn heads everywhere. Running a Wolbachia sterile male program costs a fraction of what traditional insecticide campaigns demand, and unlike chemical spraying, it builds no resistance. There is no residue left in waterways or soil. There is no reapplication cycle. The males do their work, the population collapses, and the factory keeps supplying the next wave. It is, on the evidence available, one of the most cost-effective disease control tools ever developed, and public health systems around the world are starting to realize they cannot afford not to take it seriously. The factory in Guangzhou now runs every week of dengue season without pause. Tens of millions of males loaded into containers, handed to field teams, carried out into the city on foot and by drone, released into neighborhoods where families live and children play outside after school. The people walking beneath them will never see a single one. They just gradually, quietly, stop getting sick. What began in a single lab, a microscope, some mosquito eggs. One scientist who refused to stop believing that nature could be turned against itself has grown into the most ambitious biological public health program in the history of civilization. For 10,000 years, the mosquito has been hunting us, killing us, winning. It turned our own blood against us, used our bodies to carry its offspring from city to city, continent to continent, across every border and ocean on the map. And now, inside a 38,000 square foot building in Guangzhou that looks like nothing from the outside, something is finally hunting it back.